So we would like to introduce a procedure to work with the voltammetric analyzer TA4000 to investigate heavy metals and other elements and compounds, organic compounds as well. So what we are doing here, we start up with measurements of copper. And therefore, we are using a copper standard solution. Now we inject. Yeah, thank you. We are going to inject a certain amount, sample of the copper standard solution into our measurement cell. The cell now does contain a liquid from a mixture from sodium acetate buffer and deionized water. Now we have injected and we do activate the stirrer. Stirrer is running for a while, and after that we start up the scan, the measurement. We build a new mercury drop at the end of the capillary shaft of the mercury electrode, and then we start a measurement beginning with a short accumulation time. This is the time within the lid, the copper 2+ ions shall run to the surface of the mercury drop of the mercury electrode, and after that accumulation time the scan does start, so in the range from -400 millivolts up to +100 millivolts in 10 millivolt steps. What we expect is a peak. Here it is at the well-known characteristic potential of about -100, -90 millivolt. And so now we finish the scan at +100 millivolts. So here's the peak, and now we can go to the evaluation, the German word Auswert. So now, after we have done all scans, we start up with the evaluation. We have done what we have not shown. We have done the first step. We have done a scan with a blank, so that means the electrolyte solution with a buffer without any copper solution, without any standard and without the real sample. So what is the standard here as well, of course, due to the demo situation. And so now after that, the sample, the lower peak, 2 peaks. We have done 2 scans with the blank and with the sample, 2 peaks. That is what you have seen firstly, and then we have made a one-step standard addition. So the method so instead of the calibration, standard addition, and we have injected a certain amount of the copper standard solution, and then we have done 2 runs as well. And so now we have to locate. You see the maximum here as on the scan, and now we have to locate the maximum, the local maximum of the copper peaks. So done. And then we receive the linear regression graph, so which is a certain line that regresses the measurement points of electric current in the range of micro and nano ampere. And then the program, the evaluation part of software does calculate the final resulting concentration of the sample, of copper in this case.